Welcome to all, and I have started a few minutes ago to the other people, and the first thing is my apologize for my English that not is the best, but I hope we can communicate. And in case, don't hesitate to stop me or ask me to repeat if you don't understand or my English not is enough to explain all the thing, but please stop me. Don't hesitate. In addition, I would like to tell you that we have created this training. The program of this training is to have a complete overview and understand the audio system in totally from the small to the bigger thing. But if you have additional question, additional curiosity or other thing, don't hesitate to ask, because the training is for you. And I like when you are completely happy of the training. Okay, don't hesitate to ask me what you want. Okay. This morning, the idea is to explain you the overview of the VOSIA system. VOSIA system is the system that you use in the moschea for the audio announcement and the evacuation message. Basically,
Marco, sorry,
the
you can record.
yeah. VOSIA system is the system that we use for the evacuation and the announcement inside all the area of the moschea, like the prayer room, but not only, the parking, the office, all the area have announcement by the VOSIA system. I'm sorry, I introduce you my colleague Matteo that helped me.
Hi, good morning, everybody.
When you don't understand me, ask you is better of me.
Maybe. Let's try.
And we help together to explain all the things. We come back. Why we have proposed 5 years ago the VOSIA system for your application? Now start to share my my PC, my presentation. Condivisione. Ok. Okay. What is VOSIA? VOSIA is a paging system for the audio system, of course, but basic in a network. VOSIA was the first system completely basic in a network system. After VOSIA, a lot other systems start to use the network to connect together amplifier and all the things. But VOSIA was the first system where the network carry on the control, but also the audio in the same network. Basically, by the single cable, we move audio and control of the system. The other particular of the VOSIA is that VOSIA don't have a central point. No, don't have a central point. But is a system where each part of the system have inside the control of the single part. Now, step by step, you understand better this concept. Is a fully scalable infrastructure because if you want adding an additional amplifier today or tomorrow, you can buy one and adding one amplifier without problem. And least but not least, the safety standard, in particular, compliant at the EN 54 rule for the evacuation system. This is another thing because VOSIA could be a system, but VOSIA can communicate with other systems like the biamp overview of the system. For example, in pre-room, we have we have a Tesiria system managing all the microphone, the speaker for the normal use of the room. But at the same time, we have VOSIA for the evacuation message and work together in for some speaker or some input, they can share together the information. This is another kind of audio system. For example, the preview audio system for evacuation, where we have a central point. In this example, we have a matrix, where the matrix send the input by microphone, have a control, and send the signal to the loudspeaker. But if we have one problem in that unit, in the central unit, we don't, the system don't work. We don't have any signal pass to the loudspeaker. The VOSIA concept is completely different. This is the VOSIA idea. All the devices are connected by network. Sometimes we can have the W switch to redundancy reason. And all the information is shared by network. In this way, we don't have a single point of failure. If we have a problem inside of one amplifier, we have the problem in that amplifier, but all the other amplifiers working. If I have a problem in one microphone, the other microphone working. This is the concept of the Vocia. Basically, we have 4 different kinds of device in Vocia. Now we start step by step to analyze and use the word that you find in the software this afternoon. We have the input device, could be microphone from desk, microphone from wall, or audio input, generic audio input. We can have in opposite the output device. Basically, there are amplifiers of Vocia or analog output. And we have other 2 devices. The server. The server is more or less the controller of the system. And another device that you don't have in your application, the server for text-to-speech, where you write a text and automatically the system reproduces the voice of your text, but you don't have that. And the control device that the wall control, but you don't have that because you have all the control by the server. Basically, this is the 4 devices that we can have in a Vocia system. Start with the very simple setup. 1 microphone and 1 analog output. Connect by a switch. The smaller thing, like the microphone, are completely supported by the cat cable, because by a single cable, network cable, we have the audio, the control, and the power by a switch with a PoE power inside the cable. When you disconnect or connect the cable, you automatically give all the information, all the things to the paging desk. And for this reason, it's simple. If you want in the future move that unit by a cable or in the infrastructure, you can change the position of the paging where you want. The system can increase or become more complex. For example, in this situation, we have a microphone and the other output. But in this example, we have add some amplifier, some other microphone, and the server, and what do you want? When a microphone sends a message, inside the microphone, or the unit, send in a channel the audio signal, of course is a data signal, not an analog signal, by the switch. The switch send this information at all the device in the network. Each device receive the audio from the microphone, and inside that information, there are some information where this message will be sent. Zone 1, zone 2, zone 5, or where you want. And automatically, the amplifier 1 or zone 1 or each device open or close that channel at that microphone signal. For this reason, we don't have a central device, but we have a signal that start, go over at all the device, and each device receive the information. Could be that this is your situation. We have inside of all the building of Muschia, the single system. For example, building A, building B, building C, and so on. Each building have one system, but building B can communicate with the building M, for example, building D, okay? But inside each building, we have more or less a single system, after you understand better that. And Vosia use this name. A single building is a word. All the Muschia is universal, a universal, okay? We have one universal where inside of a universal we can have single or multi word, okay? To connect one word to another word, we need of a server. After that, we see better this concept. When Vosia send a message, use a kind of message not fixed, but a dynamic, is called dynamic multicast bundle. We see this concept step by step. What means that? For example, here we have a background music. The background music is a message, is a channel that is always, or basically for 5 years of the day, but for us is always. For this reason, we use for background music the channel fixed. For the message by microphone, we normally don't use a message for the same zone. Each message change, for example. Now I select zone 3 and 8. After I select 1 and 2, and any moment change. For this reason, this kind of message don't use the fixed channel, but use the dynamic channel. When I push the button 3 and 8 and push talk, the system send a message to the zone 3 and zone 8, and then enable my microphone for only that zone. For this reason, we have the combination of dynamic multicast bundle and fixed bundle to optimize the performance of the network. In other way, if we fix the channel, we use or occupy a bandwidth inside the network, but for example, all the day, but use this bundle is used only for few minutes in one day, and we waste that bundle because don't use a lot. For this reason, Vosia use dynamic and fixed channel. The Vosia system work with the Kubernetes network protocol. After this presentation, I have created a small part where we explain the Kubernetes protocol, just to give you an overview of that protocol. One important thing is that Kubernetes is a layer 2 protocol and don't use IP. But the IP is seen only a few devices, in particular at the server or al LS1. LS1 is the life safety interface. Andare avanti un attimo, se ti do il mouse e così.
Okay. From the hardware point of view, the majority of the devices are powered over Ethernet, so we can use the switch to power the microphone paging base or the call station and so on. Also, the V6, for example, the input devices is powered over the Ethernet and so on. This is really useful because in this way we have in a single cable the power to put up the device and the control via the Vosia software, and then the signal, obviously, which, as Marco told before, is based on Kubernetes protocol. And this is what I just say about this feature. And from the hardware point of view, all the units are identified on the Vosia network by these ED switches. So in the back panel of the device, we have these two hexadecimal device CD switch that we have to configure to properly detect the right device within the software. For example, we could have several identical amplifier, and the only way to detect properly the single unit is to set up a different device CD for each amplifier, for example. But this is the same approach for all the device in the VOSIA universe or in the VOSIA world. The audio within Kubernetes is converted at 24-bit audio and 48 kilohertz sampling. So the audio is encapsulated within the protocol, and this is the sample rate and the frequency of the sampling. Okay, this is the one of the input devices, the VI6, and this is a 6-channel input device that we can use to convert the analog device in Kubernetes for use these sources as active source.
Un'altra presentazione dove dimostriamo, qua sono alcune
Okay. Okay, this is just a first approach to the device. Then we will see more in particular later. Okay, this is what I was saying before. This unit allows the analog audio to enter inside our VOSIA system and so to convert the different sources for background music or for user assignable input in Kubernetes.
ED.
Yes, the two. This is the device ID switches. So we have to configure properly. If we have two VUI6 input device, for example, we have to configure the first one with the ED1 and the second one with ED2. In this way, the software is able to properly detect the two different units, and we can configure each unit differently based on the system needs. The format is one rack unit. So we have 6 input, analog input in RCA connector or Phoenix connector. It depends on the format of the sources. And then we have 2 mic line input with the proper pre, and this is the value that can amplify in this way. And we also have phantom power for condenser mic or electret mix. 4 of these 6 inputs are line input, as I said before, balanced or Phoenix connector, and unbalanced with the twin RCAs for mono or stereo sources. The same, we have the 4 RJ connector that are used for 4 paging input. And in this specific configuration, in these 4 connectors, we have 4 paging input, which allow to use audio and data. So Kubernetes and control for the we have several status LEDs that for signal presence and signal clip. And each of these inputs have a fixed chain inside the DSP, so we can control gain, filter, equalization, or dynamic via the software. In addition, thank you, Marco, we have 4 control input, so for GPI in and for GPI out, and you see them on the right of the device CD switches. So this is the output and the input control.
If you see one particular thing, this device don't have the WRJ45 connector. Why? Because this device not is a thing for evacuation concept, but is a thing for background music. basically for background music. For this thing, the background music not is so important like the evacuation, and for this reason, don't have the second
the secondary RJ port
RJ
for redundancy or.
Instead, other device, the important device, have all the device with the important thing for evacuation. Sorry, the W network connector.
Exactly, and also the redundant power supply and so on for coherence with the EN54 regulation.
More or less, each building have one of these devices.
Continuing with the devices that are part of the WCS system, we have the VO4, which is an output device in this case, and this allows audio to be sent from a WCS system for use with a non-WCS amplifier, so we can convert from Cobranet to analog line out, and so we can feed an external amplifier with analog input. Or in other way, we can interconnect with other equipment inside the systems.
For example, in your situation, we have this device inside the pre-A room, because in the pre-A room we have a lot of axis interlock loop speaker. That is a particular kind of a loop speaker with a two input, one coming from the zero system for the normal situation where you have the pre-A inside the room, okay, by radio or wireless microphone, where you want from the normal situation. In the parallel way, we have a more WCS VO4 that send the output to the second input of each loop speaker with the priority inside of the loop speaker. When we have an emergency message, the system sends the message to this device, and automatically inside of the loop speaker, we have the priority of that message. Okay? Sorry?
From the hardware point of view, also this device is one rack mount unit. And we have, as said Marco before, for output balanced with the nominal output of minus 10 dBu, 0 dBu, or plus 4 dBu. It depends obviously on the level of the kind of signal that the loudspeaker are asking for. Also in this case, as for the i6, we have the status LED that allow to monitor signal presence and clip. And as in the previous device, we have a fixed chain inside the DSP that allow us to manage gain, filters, equalization, delay, because we are talking about output. So in this case, it's very important to apply the proper delay to the system. And in the end, the dynamics control. As for the VI6, we have 4 GPI in and 4 GPI out for control external device or to catch control input or output on the field. And in this case, also, the VI6, the unit is PoE powered, so we have the switch that allow to power up the two devices that we've seen until now. About the microphone station, we have two different wall station. In this case, this is the microphone paging station dedicated to wall mount, as you can see from the hardware format. And the WS4 and WS10. The difference between the two call station is that in with the WS4, you can reach directly a maximum of 4 zones, while with the WS10, we have the numeric keyboard that allow us to a more complex and paging system, and to reach a larger amount of zone directly.
Just to explain, 4 button not is a 4 zone, is a
Exactly
4 group of zone. Okay, could be button A, zone 1, 5, 7, what do you want? But one group. The second button, you can have, for example, total, all the building. Or I try to do another example. Push button A, you have building A, B building B, C building C, and D building D, for example.
Exactly.
But each building have a huge number of zone. But you can associate at the single button a lot of zone. In another example, the Busia US10 can select tilde 999 different page code.
Exactly.
A page code, another kind of word that we will use inside the software. A page code is a preset or a situation where you choose which zone you want to assign to that page code. I can create how many page code, one to each zone, or one with one zone, and the second with 10 zone, the third with all the building, the fourth with all the building, and the second building. What do you want?
Yeah.
Okay.
Yes. Okay. Then we have the desktop version of the previous microphone station. So the functionality is quite the same, but the hardware format is quite different to allow the positioning of the desk station over a desktop. So for use it over a table or something similar. From the functionality point of view, WS4 and desktop, so DS4, are the same device. So you can select up to 4 page code via direct entry. So with the 4 button, we can select directly 4 page code, while with the WS10 and DS10, as Marco said before, you can select up to 999 page codes, using the integrated keypad. And the wall mount are equipped with a noise cancelling microphone with a dual transducer, and the microphone capsule is monitored by the software, so we can have an alert, or we can read the log for detect further problem related to the microphone capsule. The DS model is equipped by a cardioid microphone with a dual transducer, and also in this case, the microphone capsule is monitored by the software with the same modality. The VUAS is an emergency page station. This means that if the microphone call station disappears from the system, the device, the life safety device in the Busia system signal to us that the microphone call station has been removed or the cable is broken. So we have to restore as soon as possible, because it's a crucial element in the evacuation system.
we can choose if that microphone wall mount could be a normal microphone or an evacuation microphone. We can choose by the software. This means that that microphone, when we chose that is an emergency microphone, become a very high priority microphone with a very important microphone. For example, for the fireman, I don't know, if you have a point where the microphone go to talk with the system, that microphone is very, very important. Okay.
That said, we have a backlit LCD screen which allow interactive operation, for example, recording message or the selection of the proper message to play. And we have a PTT switch and LED indicators for active paging. Okay, we have two soft buttons that allow configuration by the LCD screen. You see in the front panel. And this is what I was saying in relation to the message selection. We have the priority and store and forward. This means that if I play a message with the same priority over another source, the system autonomously store and reproduce then the message when the priority line is free.
Probably in your situation, you don't have a lot message, but when we think, for example, in airport, where there are a lot of operators that send a message and in the same time, this is a very interesting feature because you can send a message. Is in the meantime, Matteo is sending in that or other zone another message. My message that have a priority level below the message of Matteo is stored inside the server, and when the zone is free, because Matteo have finished the message, my message is sent to all the zone that I have checked.
Yes, it will start automatically without any human intervention. We have also the possibility to select different preambles, so we can upload different chimes for the preambles, and they are stored locally inside the call station. The level of the chime is adjustable in the graphic user interface. And we have also a fixed processing line, which is composed by equalization, dynamics, and gain for each microphone station. Another important feature is the optional delayed page. We can set up a delay to wait for the message to be played. And we can also set up an optional pin for the access to the microphone station. Then we can switch to the control device. We have the WR1, which is the wall-mounted remote. We can use this to adjust the volume in an audio zone, to select the background source for each zone. We can also inhibit the paging in a specific zone, and we can gang the control if we need to control several zones with a single volume control. As you can easily understand, this kind of device is very important because at the end, in the majority of the system, this is the only interface that the final user can approach to control the system. So if you have to adjust the volume or to switch from a background source to another, this is the easiest way to do this, obviously without interacting with the software.
Okay. It's okay. It's boring, more or less, but we hope the others should be better and more interactive. But this is important to understand the first concept of the Devosia. E tu faccio io questo.
Cos'è l'altro?
Aspetta, che non ho condiviso, scusa.
Question? Okay.
Few slides
Marco,
just to
Marco, sorry.
explain.
There is some question.
Yeah, please.
Marco, please, in the first or the second slide, there is a mention of the safety standards UN 5416. Could you give us more details about the relation between these standards and our system?
The standard EN 54 is an international standard rule, and you can try to download all the information of this standard. Basically, there are a lot rules for the device, and an external authorization company give to BIAMP the compliance of this rule. What means that? That the amplifier, the microphone, so must have some feature, very particular feature. For example, if I disconnect the cable from the central point, at least after 1 second, we must have a signal where we explain that there are a problem. Another thing is inside of the system should record the message of the evacuation or other thing. The microphone control of the if is broken.
Monitoring.
The monitoring of the loudspeaker connector. This is just to explain you some of the requests inside of the EN 54 rule. The company BIAMP send this object to the other company, Matteo, for example. Matteo check 1, 2, 3, all the thing, create a report, and at the end, send or give the certification if the device have all the thing right in this row. Okay. Basically, we have 3 kind of EN 54. 5416, 54, 24, and 54, 4. For the audio system, we use the 16 and 40, 24. 16 is for all the electronic. 24 is for all the loop speaker. Also, a loop speaker must have some characteristic. For example, the fire dome, if you use the ceiling loop speaker, or if you use an external loop speaker, they check that the loop speaker can
Fire resistance.
have a fire resistant for example, 1 hour inside of the fire, okay? To be sure to give during a fire the message. I have replay your answer. You want additional information?
Yeah, thanks. So it's according to the system, not to the safety people or other things related to that.
Can you speak nearer to the microphone because it's quite
So
difficult to hear.
it's according to the system, not to the other things.
Yeah. It's a certification that the device have or don't have, basically.
Thank you. My second question, it's about the device ID for identification.
Yeah.
It's just a choice to use the device ID or there is other meanings for that, because as you said, it's work in the network. So why they didn't use the MAC address of equipment to identify each equipment, and they use this device ID? And what's the difference between MSP and LSP? Okay.
The reason for the device ID is basically because in this way you can swap the effective unit without reconfigure the system. So if you have an amplifier which has ID, for example, 1, you can uninstall the broken one and install a new amplifier with the same ID, and then in this way the amplifier will configure by itself. So you don't have to resend the configuration to the system, and you don't have to apply any other step to have the system working properly. And this is the reason, because you can because the SIA system is based on the ID concept instead of the MAC address, as you asked before.
For example, in your Moschia, you have more or less 50, 60 amplifier. Each amplifier have a different ID, okay? If you have broken the amplifier of, I don't know, Minareto with ID 23, 24, for example. You remove that amplifier, bring the same model of amplifier, of course, change the ID, and you configure the new one with the same ID, connect the network cable, connect the power on, and automatically the system, in this case, the server, send the configuration at the new amplifier with ID 24 and send automatically the configuration. And automatically that amplifier starts to work like the old that is broken.
And then about the difference between MSB and NSB, they are two, you can add several devices, and so you can, you could need a huge number of ID. So you have the first number for starting from 0 to hexadecimal, and the second one the same. So you can have a a huge number of devices using these two ID regulation.
Most important, least important number.
Yeah. The
Bas-
first one is the most important, the second one is the less important.
Basically, each rotating cover have 16 position, like the hexadecimal numeration from 0 to A, B, C, D, E, F, if I don't work.
Yeah, yeah.
The same for the other one. More or less, we have used, for example, the first number for the number inside of the rack. The most important, the second number, for example, to identify the number of the rack. For example, rack 1, the second number is 1. The third rack, the second number is 3, and more or less this philosophy. But not is important. What is important is that to have the same number from the configuration to the number inside of the device. Okay?
Okay, thank you. Just one more thing. Could you just give us, please, some details about CobraNet protocol?
Yeah. After this few presentation, and we have. Okay.
Okay.
Or if you want, we can do now. But
no. If it's already programmed, we can see it later.
Yeah.
No problem.
Yeah.
Exactly.
We have. You have.
Thank you so much.
Okay.
What is the word in the Vosia concept? The word in the Vosia, we have basically a universal and a work. In your system, the idea of universal and the world is perfectly because each building is a world where in a world we can have a number of zones, a number of microphone, a background music, and what do you want? Inside, or we have a lot of word because in your mosque you have a lot of different buildings. But basically, if you for example, lost the communication between one building and the other building, it's important that the single building can work standalone. Okay? For this reason, each building is for this idea independently from the other building. But on the other hand, sometimes we need to have the communication from one world to another world, from one building to another building. For example, from the building A, where you have the prayer room, we can connect the minerato to send the same message, okay? But are two different buildings. And in this particular situation, we have a communication called inter-world communication. Okay. The Vosia system can have at a maximum 50 words inside of one single layout, and inside of a word we can have a maximum of 256 zones. Basically, we can have 256 multiply for 50 words, a huge number of zones. Okay. The zone is the single or multi-line of loop speaker. We can have, for example, the parking. We have a bigger number of horn inside of the parking. But basically, the parking is divided in few zones, 3, 4 probably. But we have more or less, I don't remember, but 80 line of loop speaker for the parking. What mean? Mean that each line of a loop speaker can combine at the same zone. Okay, we can have one line, one zone, or we can have more of one line in the same zone. Okay, and the other thing is we can have, for example, zone 1, channel 1, amplifier 1, and the same zone in the amplifier 4, zone, line 3, for example. Okay, we can combine which we want in to combine together the loop speaker line.
This is an example that can help to understand better the composition of a system. So if you take this example into consideration, this is a virtual airport, and we can consider the different terminals as a different word, okay, in a Boursia system. And the whole airport is one universe. So we can have terminal 1 as word 1 and so on. And analyzing in the detail, we can, as I said before, consider each terminal as, so each terminal building could be a word, and inside each word, we can have several zones. So we can see, for example, the concourse C, which have C7, C6, C5, and so on. And these are all different audio zones. So, for example, the gate is a zone. Each zone can have multiple speakers. So you can easily imagine that a Boursia system is structured into different level of detail, starting from the universe, then the building that are words, and then the audio zone, and inside the audio zone, the different loudspeaker line with the loudspeaker connected. Okay. Another important factor to analyze is the paging code. A paging code, as we said before when we were talking about the microphone station, is at the end is defines the destination of a page. So by inserting the proper page code, we can reach one or multiple zone to diffuse the message. A zone, as I said, can be included in multiple page code. So I can have different page code that can reach the same zone. And a page code cannot exist without a zone. So this is quite clear, I assume, because we cannot have a page code which does not contain a zone at all. inside the page code, we can define several properties. For example, the paging mode, which could be live paging. So I define the zone that I have to reach. I press the talk button in the microphone station, and then I speak inside the microphone that equips the call station. The other way is the pre-recorded message. So I select the zone another time where I have to diffuse the message, and then I select a pre-recorded message that the system will play automatically. Obviously, always referring to the selected zone. We have the possibility to configure a preamble, so a chime, the typical 3-note, 2-note preamble that that alerts the people that a message is going to be played. And then we can configure a delayed page for to allow the message to wait a predefined range of time. The page code have different priority level. We can take a look to this as a low, medium, high, or urgent. Okay, so it depends on the level that we configured within the page code. So a different page code could obviously have a different priority level. Okay, this is the configuration of a system like the system that we have in our room. So we have unmanaged switch in this case. So just to show that it's really simple to configure a system also with an unmanaged switch. And we can connect to the POS switch in this case the WS10 and an amplifier, in our case VA4030, so it's a 4 channels amplifier. Then we have the message server 1, which is the central unit and the real server of the system, which allow to save the message inside the device. And then we can also use this device to save the configuration of all the system. So in this case, with a server inside the system, we can automatically manage the device swapping as we described before. Then we have a VUI6, which is the input device for the system, and in this case a modular amplifier, which is the VA8006, that I assume is the amplifier that keeps the system in the Moschea, which is a modular amplifier that you can configure in several ways to reach different results. Okay, then we have the description of the switch. In our case, the switch is quite different, but we can manage to detect, to discover the unit via CobraNet. So it's quite simple to act in this way because you don't need an EP configured inside your network interface, because CobraNet, as we will see later, it's a layer 2 protocol that has no EP address, so it only acts by the MAC address of the device. So you don't need a specific configuration on your PC to reach the device by CobraNet. In this case, assuming that we have an MS1 server, we can differently detect the unit by connecting to the message server, which obviously has an IP interface, a TCP IP interface. So we can configure our PC to stay in the same subnet, and then we discover the covered device by the TCP/IP connection with the server. Okay. I assume that this could be clearer during the afternoon when we use the software and we see the different way to discover the system.
One moment. Do you prefer to have a break now, or we wait the next presentation? We have a break after the next presentation. What do you prefer? Okay.
Next presentation, please.
Okay. Okay. Condivido. Sono uscito.
No. Hai interrotto la condivisione.
Sono uscito io.
Ah sì, vabbè, basta clicchi, sì.
I'm sorry. Next step. We have talk of VCA system, but right now we don't have a talk of the evacuation. Now we explain the feature that need to have the system where is used for evacuation system. The law asks a lot of things, but we can give this information. All the system of evacuation basically was a file detect system that you have, for example, and by one or more contact, that system close or open a contact, and after that start the evacuation procedure. For example, stopping the background music, enable the microphone, start the message, what do you want? The new requirement asks that we can have inside of the same system the background music, but when we have the PR system with the evacuation system, we must have this thing: redundancy, interface with the fire alarm system. For particular unit, have the including the W power supplier, we have the power from high voltage, but the battery, okay. The monitoring sound or lamp output to explain where there are problems in the system. In particular, when we have a problem in the power, in the audio path, and in the network. For this reason, VCA system introduced a life safety interface, LSE 66. Each word, now you understand when I talk of word, must have at least one life safe interface. Why one? Because basically we need one interface to communicate with the fire alarm system. But sometimes for huge system, could be that we have more of one LSE16 because, for example, you need to have in different part of the building or for a huge number of the contact and so on. The system must have at least one amplifier, of course. Amplifier VA8600 or other kind of amplifier or smaller. This is the smaller evacuation system. One interface and one amplifier. Why? Because by one amplifier, we can have inside the message, the evacuation message, directly stored inside the amplifier. And the LSE16 is the device that talk or by contact close or other way with the fire alarm system. The fire alarm system switch a contact because they are the fire. Automatically, the LSE send the message to amplifier, and the amplifier start to play the evacuation message in red or more zone. This is the smaller evacuation system. In addition, we can add one or more emergency paging station, and we can add more zone, more other things. But just for understand, this is the two smaller or the smaller system for evacuation system. All right? How work? The fire alarm system send a contact, a message to the LSE, and automatically LSE disable all the device not for evac and
classified as an emergency device.
Enable only the emergency device and start to send the message, start to send the message in that zone. Of course, I can have one or more emergency workstation, and if I want or depend by the priority that you have stored in the system, this paging desk can send the message with a priority over the message or below, depend of the priority. It's clear? The lefty safe interface, is designed to meet the row inside the EN54/16. Basically, they have in the frontal panel all the indication by the LED of the power system, general fault, general alarm, power supply, system fault, and additional zone number. In the real panel, we have basically the two connector of a network. In this case, you see that we have the two connector because we have the maximum redundancy level of the device, and we can connect the port 1 to switch 1, the port 2 to switch 2.
This is obviously because the real redundancy, you can obtain the real redundancy only by using two separate switches and two separate networks, not connecting two ports to the same network, because if the main switch fails, all the system go down, also if you have two ports connected.
This unit is powered by PoE from both, but can have an additional secondary auxiliary power supply. Have inside 8 monitor output, 8 control input, in particular for emergency detection zone, and this contact is monitoring input to check if the contact is active or not, and system fault. In addition, we can have 2 additional slots. The additional slot is, you see that, with additional contact input or output. Sorry. In particular, for the output, we can have more or less what we have in the front by the LEAD, and basically we have the load fault or alarm and sounder, general fault, voice alarm active. This is active where or we have one message play from a contact, for example, or when we have a message from a paging desk, but the emergency page desk. PSU fault, for example, this is for some reason a pass-through we see below. A protector fault, a transmission patch fault. This means that we have a problem in the network. We don't see the amplifier in the building C. Probably is a wrong thing in the network, for example. And auxiliary PSO okay, and external supply over voltage monitoring. We have, in additional, the input. The first 4 input is to sound signals, voice alarm signals, test and fault reset, and PSU fault. This could be, for example, used when you use the UPS to have the maximum security in the power supply, for example. But sometimes the UPS have a problem, battery or what do you want. When the UPS give the information at the VOCIA system by that contact, the VOCIA system understands that we can have a problem in the UPS, and from that moment, disconnect or disable all the background music, for example, to have the battery save in case of the message, for example. The other 4 contact trigger the alarm 1, 2, 3, and 4. In each of your building, in the main rack, you have one LSE16 connect with the fire alarm system. Normally is a few contact. Sometimes in particular situation, we have 10, 12, 20 contact. If, for example, there are a lot different fire alarm zone in the building, and the audio system have the same zone of the fire alarm. For example, if I give you an example, the minareto. The minareto is a very big building, but for example, we have a fire in the 21 floor, okay, and the system gives us the information of the fire is a 21 zone. For example, we start to send the message, not in all the minareto, but we start from the 21, 22 floor, and for example, the floor over 24, 26, 27, and blah, 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 okay? After that, we probably start to evacuate the floor below 20, 99, and 18, and so, okay? This could be a user with a very clever system combined from audio and fire alarm system. We can create what you want by the programming. Okay?
Marco,
Have you
please.
question?
I
Yeah.
have a question. In the schematic, we see the connection between the VOSIA system and the fire detection system. Could you give us more details about the connection between those systems, especially if we are in the third brand in case? Which protocol, which requirement?
Basically, with the fire alarm, normally we use the contact. We can have three kinds of contact. Normally open, normally enclosed, or monitored contact. Normally open means that you don't have any signal. When you close, you short the connector number 5 with the ground, start the message. Normally close means that you have the contact close, short, between the pin 5 to the ground. When you open that, okay, disconnect, the message start. The monitoring means that you have a contact. I try to check if I can show you by VOSIA monitored contact manual. Vediamo se troviamo. I'm checking if I No, forse l'LSI1.
Sì, i contatti ci sono.
One moment, I'm checking. Allora, giusto.
But it's a short choice for security, or why they didn't go, for example, to work in the other protocol, like Ethernet or for security?
You see my screen?
Yeah.
You see?
Yeah.
Okay. This is the different kind of contact, okay, that we can have with the LSE 16. This is a high range monitored input. This means that we have between these two contact 24 voltage, okay, by a resistant, and when you switch the contact to high voltage, automatically start the message. This is a high state. Sorry. Passiamo un attimo perché col coso. Sorry.
It's always compatible.
Normally, this is the kind of the context suggested, because it's the more readable message to the system. But you can have the single state high, okay. When you go to high voltage, the system is enabled, or with the low. You have normally a contact to 24 volt, okay. When you switch to 0 or open, automatically start the message, okay. I hope to have answered your question.
Yeah, it's clear now. Thank you, Marco.
Okay. This is inside of the manual, but I can share it, this manual, or you can find in the web browser by this the manual of.
Yeah, later we can show you the cornerstone of Biamp, which is a really useful source of information in WCS system and also in other platform developed by Biamp.
Okay, thank you. Marco, please, could you go back to the schematic of the emergency plan with fire detection? No, in the presentation.
Oh yeah.
Sì. Avevi aperto prima la voice evacuation.
Questa.
C'è Audacity to Work. Se vuoi ce l'ho io.
No, cosa voleva vedere?
Lo schema dove c'è la centrale antincendio.
Do you mean
Ora condivido.
Aspetta che facciamo così, ci vediamo.
Vado.
Vai, se vuoi.
This one?
Yeah, this one. In case we have the emergency from fire detection, you said that we
Yeah.
disable all the things, expect
The
emergency
non, yeah, you deactivate all the non-emergency devices. So if you have a microphone station, for example, the one on the right, the EVS 10, this is an emergency wall station, as you can easily understand from the name. And in this case, this remains active. While the desktop, the DS10, which are not emergency devices, they are deactivated automatically from the system. The same behavior is for the VI6, which is only a BGM, so a background music source. And while the amplifier, which are strictly related to emergency zone, remains active and play the message in the respective zones.
And in this case, we have only automatic message, or we can prepare a normal message in case we
Yeah,
need,
you
for
can.
example, to pass another message manually on the system.
Okay, the message starts automatically by the GPIO, but you can configure the message that you want. You can personalize the message. You can upload the message in the server by yourself.
The message is inside of the amplifier. Okay.
In case, for example, we need to pass another message manually, it's possible or it's
No,
not possible?
no, you need to bring your message, put in the software, VCA software, and send the new message to the system. Okay, you can do, but you need to have the software and
I want to pass another. There is no way.
yeah, you can do, of course. But when you have done, is inside of the amplifier. Okay.
Clear. Thank you, Marco.
Okay. Another thing that you can have when you switch a button or a contact, a message, for example, one in the zone 1, and a different kind of a message, for example, messenger 3, in the zone 5, 6, 7, for example. Okay. You can programming, and we see in the afternoon, the message and for each zone, sorry, emergency zone. The emergency zone is different from the zone, but this afternoon you understand better. Okay. I suggest to have a small break. I start with a very quickly overview of the product. All the concept I have explained with the preview slide, but here I would like to use this presentation because we have all the device inside. We talk of the input and output. To be complete, inside of the input device, we have additional thing. For example, we explain the VE6 input. Basically, is a device using for background music. But we also have the VE8 input. What is the difference between the 8 and the 6. The basically is the number of the input, but notice that the very important difference. The important difference between the VE8 and the 6 is the kind of the input. Because with the VE8, we can use one input like a paging or like emergency message. For example, if we receive from other system the message. Why that? Because the VE8 have a W port. Okay. Another kind of device is the VoIP 1 or VoIP 2. Okay, is a device that can connect an external telephone system with a VoCR system. The other one we have a C, but just to explain you, we have show only one kind of amplifier. Now I show you the other kind of amplifier. And other thing is the ANC1, ALD1, and PLD1 or 2. Now I explain you all these other things. I'm sorry with the W. We have seen this device, but we can create a device more complex. Okay, this concept we have seen. Now we told you have seen these two paging desk. Okay, the wall mount desk, the simple microphone, but not is so useful. This could be another additional thing, sometimes used, sometimes no, to create yourself a microphone desk if you want to create a custom microphone desk. The input VE6 that I show you, and the VE8. I show you, or I talk to you, that this device have two connection to be sure to connect at two different switch. If you want to use the input for evacuation, you need not the VX6 but the V8 for this reason. Okay. We can have the POTS 1, but is very old, this device, because we can have a connection to the analog telephone system, very old style. This is the VoIP system. What means? We have two ports to connect this device at the VoCR system, and two additional ports to connect this device to a VoIP telephone system. This device is like a bridge between a telephone system to the evacuation system. You can configure this device like a telephone. You put a code in your phone, and automatically this device send your call by phone to the zone that you have programming, like a call without the phone. Okay.
Marco, please, for VoIP, it's like a tunnel or one line for each port for the VoIP.
You can have two two number, like two different phone for each port. This means that you, in this case, can have simultaneously 4 different 4 line, okay, and you can have in the same time calling in a different zone. I explain you. Is it clear?
Yeah,
Okay.
clear.
Like you have 4 different phones, okay? Each phone can send to one or more zone. What do you want? Okay. Of course, if by your phone call zone 1 and Matteo send the call to zone 1 and 2, depend of the priority, okay? If you have a priority level higher, the call of Matteo is store and forward, and when you have finished, the call of Matteo is sent to the zone, okay? Like with the paging call, like with the microphone, the standard microphone, of course, okay? Now show you the different kind of the amplifier. This is a smaller version, 2 channel and for 60 watt for channel. This is a second version, 4 channel, 30 watt for channel. This is amplifier very smaller for small situation. This is the other 4 channel, 300 watts for channel, or this is 8 channel, 150 watt for each channel. At the end, we have the big one. This is an amplifier where we can have a total amount of 2,400 watts, but you can program a number of channels from 1 to 8 with a power of each channel different. Each channel could be programmed with 100 to 600 watts. Okay, 1, 2, 3, 4, 5, 600 watt to each zone. But the total amount of the power of the card, the total card, the card could be 1, 2, at maximum 8. The total amount is 2,400 watts. Okay. At the end, the output for send the message to other device. You have the VO4E. E is the version with the evacuation system, and inside have the message. You have this model. There are additional devices for to have the complete system. In particular, this is another device, ambient noise compensation device, where we can connect 2 microphones at this device, at these two pin, okay, here. And by this microphone, we can increase or decrease the volume of the zone in compensation or by the situation of the noise in that ambient. Okay? For example, in airport, in a railway station, in the morning you don't have any noise. In the midday there are a lot people, a lot of crew, and a lot noise. For this reason, the system can automatically change the volume in changing during the day, during the noise of the ambient. Okay, you don't have that, but the system can have that device. At the end, we have two kinds of monitoring, or better, three kinds of monitoring of the line. The first kind of the monitoring is have a physical device like that, and offline device. This is a hardware that you connect by network, and you start from the amplifier with the amplifier line and go by all the device, all the loudspeaker in the line. At the end of the loudspeaker, you put that device, and from the loudspeaker amplifier and this device, we have a communication to check if the line is okay. This is one kind of a check of the line. This is one of the possibility monitoring of the line right in the EN 54/16 rule, because there are a lot of kind of a monitoring. A different kind of a monitoring is by the passive monitoring. What means? We can connect at the end of the loudspeaker line this module, this box, okay? Inside there are a small circuit. From the amplifier send time the signal, the input, okay? This device receives the input and replay to amplifier. And there are a communication between the end of the line to the amplifier. This device don't have a connection by Ethernet. It's a passive module. Okay, work directly by the amplifier line. Okay. The third kind of the monitoring is by high impedance. We can enable inside the amplifier to check the loudspeaker line by checking the high impedance of the loudspeaker. And we see this afternoon that we can show you this third kind of the monitoring. But this kind have some problem when we have a lot of loudspeaker, because not is so precise the measurement of the impedance. And sometimes with that kind of monitoring, we aren't very sure if we have a fault or no fault with the passive or the active. And the line, we be sure to have or not have the line connected. Like the controller, we have the GPIO1. This is a generic device with 16 general input-output to enable additional feature, for example, start a message, close and disconnect or mute the background music, or any other feature to increase the number of the input-output of the system. This could be a device that used to increase the number of the contact for the message, for the emergency message. And for this reason, this device have the two network port. This network port is power over Ethernet, but we can have the power over Ethernet by this device could be power from the power over Ethernet or from an external power supply redundancy. Two different power supply. We can have 4 power supply, PoE and external power supply. The controller we have C, LSC we have seen in previous slides. At least we have the MS1 messaging processor or calling server. This is a device very particular because the MS1 we see after this presentation have a lot of different rules in the VOCIA system, but I prefer explain in the next presentation. At the end, we have the text-to-speech engine, but in your system, we don't have this device. It's very useful, for example, in an airport, railway station, other thing, where the automatically message is automatically sent by a system send the text by a TXT file or a text message, and automatically this device transforms the text in a speech. Okay. I have finished this overview, more or less this part we have seen, and I swap to the network covenant presentation. Sorry, I bring a PDF, no, the PowerPoint. Okay. Probably a lot of what I tell you now, you know. But I prefer to have an overview of the IP concept. Don't hesitate to stop me if you don't understand something and ask again. Okay? What is a network? Probably you know, a network is a collection of a computer or other device that is connected by a cable, by a connection, okay, and talk together, basically. This is a network interface. I'm sorry. I was in a different, my mouse was in a different page. Network is a computer collection or device collection that talk together. What is a network protocol? Is some rule to share from the device to use to communication between one to the other. This is more or less the network protocol terminology. Normally, we use the three kind of network extension. LAN mean local area networks. MEN, metropolitan area networks, and WAN, wide area networks. When you connect your PC inside of one of a plague of mosquito, basically you are inside of the LAN. But when you go in a web browser and want to go to internet, after that there are some device, a router, a switch, a bridge, and many other firewall, many devices that connect your PC to a door of your mosquito at the network in the world, by internet, for example. This area is the one wide area network. Okay. Another concept in the network is the ISO-OSI model, or a stack of the ISO line. Basically, this layer provide you to understand that each part of the device help you to go deep from the high level to level below, because, for example, when you use a browser, you use the application level, but step by step, the browser go deep and go at the microchip that talk with 1 and 0, okay? Step by step, we have increased this level to help the communication between the browser, top level, at 0.1 level of the device. But don't worry. This is only concept for you. For example, this OSI ISO model, the level 7 is application. The level 6 is presentation and permit to move the information between your PC to another PC, for example, with encryption and decryption inside of the communication. The level 5 is the level that maintains the communication between your browser to the server, for example. The level 4 is the level where we have the communication between the 2 points, and this level is pay attention at the error during the communication. The level 3 is one of the more important level because probably you have heard of the IP address or more or less this kind of information. And in the level 3, you have defined the packets and their addressing. In this level, we write the address of the IP address of the device, for example. The level 2 is a data link communication. Levels 2 don't have the IP address, but communicate from one device to another device directly by the MAC address, for example. This is called a physical communication type because we have the communication between a card with another card, but they match the MAC address. At the end, we have the level 1, and this kind of the level is the communication by 1 and 0 to another card by 1 and 0. I need to explain that because basically the layer over the layer 3 basically is a soft layer. Below layer 3, we have device that is Ethernet device, like switch, router, hub, firewall, this kind of the device. Okay. Another subdivision of the layer could be in this kind, where we have Ethernet, physical, for example, physical and link, Ethernet line, or TCP IP. For example, when we have a switch can have a cabling by a copper cable or a fiber cable. Both the port is Ethernet communication, but one is a copper cable. The other one is a fiber cable. They have two different physical communication, okay? But both is managed by Ethernet roles. This is, sorry if it's in Italian, but I think you can understand. If we start from the application, the layer very at the top, we can see that this is the communication. But when we go to the below layer, the package sent by one from the sender to receiver have an additional part of the data. The data is the gray, okay? When we go to the below level, the level below had one part of the communication at the important part. And at the same, the below level. When you go to the below level, the package of the information is very big. But why is big? Because we have a part of the data and the other part to adding additional information. For example, the encrypting, the error control, the IP address, the level of the network, the data information, and at the end, the physical of the 0 and 1, for example, parity and other kind. When we go from below to the high, the package is clean, and at the end, we have only the data. Okay? I go.
Yes.
Other 2, 3 information, but basic, I think you know. We can have, the transmission rate different between different kind of port. For example, we can have a Cooper port with 10 megabits, 100 megabits, or 1000 megabits, depend on the kind of port. Okay. Other terminology is when we have a star topology, is in the center, and the other is the single connection with the central point. Okay. Do you know the difference between the hub to the switch? You know, when I start the university, I used the hub because hub was cheaper compared with the switch. But what is the difference between the hub and the switch? You know? You are young. You don't know? Right? Yeah, I explain. The hub is a stupid switch. When you send a information from the PC to a hub, the hub is a stupid. Sorry. It bring the information and send to all your port. Okay? This means that if these 3 PC don't mind the information, they receive traffic. Okay? The switch have another, sorry. The switch instead, when one PC send information, check the IP address inside of the string of the who is the send and who is the receiver. If the receiver is here, in one of this port, send only that the information. This is basically the difference between the hub to the switch. In the past, the switch were expensive. When I started to study more or less 30 years ago, we have the hub because it was too cheaper compared with the switch. After few years, the hub don't exist more and use only the switch. Okay? Come back just to finish this part. Probably you know the different kind of connection or fiber optic, okay? With the cable, we can have a connection with speed width from 10, 100 or 1000 megabits. With the fiber optic, we can have speed width starting normally 1000, but sometimes we can have a device that go deep at 100 megabits, for example, media converter. With a fiber optic, we can have a speed width of 10,000 megabit or 100,000 megabit. Okay. The media converter. This is a cabling, normally cabling, where we have normally a rack 90 meter between with a cable from the rack to the plug in your room, and the connection with your device, PC, microphone, what you want, normally over 3 meters. This means that from device to the switch, you have more or less 100 meters maximum. Hub to switch, okay. Normally, when you have a bigger building, you can have a switch to floor or a switch in a part of the building where you connect the PC device near at that rack, and by fiber optic or by cable go another rack of the floor to connect the other device. This normally is your situation in a building. Level 2. The level 2 is the level that we use with a current. For this reason, for us, it's very important, the level 2. The level 2 is an Ethernet hardware, and each card have a unique address calling MAC address normally, and this MAC address is for 48 bits, normally represented hexadecimal form, like this example: 07, 01, 2A, E5, 23, 4F. These are basically a word of 8 bits, 8 for 6 is 48 bits. The last, basically, each manufacturer can ask to have a assigned MAC address reservation code, and basically is the first part of this code. Okay, the end part can to be used to your device, because you produce a lot of device. For example, the first part for the VOCIA system is always the same, sorry. The end part is different to each VOCIA device. The same for your PC, for your phone, for your all the devices have a different MAC address. Okay. The switch is the device that receives the string, the package, and send at the right device. I mean the computer, the VOCIA, the what do you want? Okay. This is the slide to explain the hub and switch difference. The switch reduces the amount of the unnecessary traffic, checking the address of the sender and the receiver. At the other end, the hub bring the information and send at all your port, the port of the hub. Okay, this is the difference. The level 3 instead have a communication by IP protocol. The IP protocol asks to assign an IP address at each device. The level 3 is over the level 2, and the level 3 communicate between address of the same range. Now I try to explain you. The IP address is a number composed of 2 parts. A 32 bits, okay. The 42 bits normally is show like 4 number from 1 to 255, dot other 3 number by 1 to 255. And this is your network number. In a network, each device needs to have a different IP address. We cannot have two devices with the same IP address. We have a problem. The second number is the host number. We can have different kind of class number, and these depend of how many devices you think to have in your network. For example, if you have your house, you probably have not a huge number of devices. And you can use the C class, because 256 host device, computer, printer device is enough. In a bigger situation like your situation, probably you need a bigger number of devices, and the step over is the B class with the 65,536 device. A huge number is a class like A class with that very huge number. This means that you use different kind of network mask. The network mask is a representation by 255, 255, 255, or other kind of number. Basically, when you have this kind of mask, 255 mean have all 1 bits. 0 mean have 0 all the bits. But you can read this information like that. With a 0, your PC, your device, consider the last number of your number. Okay. If you don't have a 0, the other number is the same. To explain, I go in the next example. For example, I have the PC A, a PC B. They have 201.2.1. Okay. The PCB have the first 3 number with the same. The last number 3 is different. The network of the PC A and B is 200.1.2, because this is the same range of the IP address. And the last name is the number different. Below, we have another kind of network. The other network is with 201.3, different the other network over, we have 2, okay? 2 and 3, okay? this is the PC D and E can communicate between directly because it's part of the same network. Okay, but the PC A and PC D not is part of the same network because one have the 201.2 and the other one have 201.3. 2 and 3 is different. If we want to combine, to communicate, to permit to communicate from two different subnet, we need of a router. The router is the device that permits to communicate between two different networks. Okay? No, adesso vediamo. For this reason, when we write or assign an IP address of a device, we assign an IP address, and this is the IP address of that device. The subnet mask is if we want to be in the class A, B, or C, different class of device. And at the end, we have the IP address of the gateway. The gateway is this device, the router. What mean? When we want to communicate between that to that, and the IP not is in the same network, all the string is sent from that device to the router. And this router send to the other device. Okay? You have 5 minutes? I finish this part. Covernet. Covernet is a rules by right from peak audio, where they write some route to communicate from one device to another device by network. In the Covernet network, we have the audio and the control carry out in the same protocol, but the Covernet is a level 2 of the layer that I explained you. For this reason, Covernet don't have IP address. Don't work with IP address. Don't use IP address. Inside a Covernet channel, we have all the Ethernet have inside the audio channel, the computer data, the clock, and the monitoring. Okay? You have the lunch time now, correct? Or I have more or less 5 minutes, but I want to be sure to be present in this moment. If you want, we jump in the afternoon. What do you prefer?
Go ahead, Marco, go ahead.
Sorry?
We can continue.
Go on. Okay. Some simple information of name. We call interface Kubernetes each device with the Kubernetes connection. The Kubernetes connection is a specific hardware because inside of the device we have a chip created by Peak Audio company. Okay. Normally we have two kinds of device, but basically the most important device have two interface, two different RJ connection sockets. Okay. The two connector is normally called primary Kubernetes and secondary Kubernetes. Inside of this connection, we have the Kubernetes device, the Kubernetes hardware, and the Kubernetes hardware have the firmware, a specific firmware, a specific configuration, and permit to communicate with the network protocol layer 2. Other important name, we call Kubernetes interface the hardware. Kubernetes device is the amplifier, the microphone, the DSP, what do you want that have inside a Kubernetes interface. Kubernetes interface is the hardware. Kubernetes device is a generic device with a card Kubernetes. Other two things is the conductor and the performance. In one Kubernetes network, we have one and the only one conductor. The conductor is the president.
The leader.
The leader. Basically is the holder in the network, the first device that you have connecting the order, but not is so important. There are a random protocol to election the conductor. The conductor is the device that send the clock, because all the devices have to receive a clock start and a clock synchronization. We have one conductor and many performer. The performer is the other device that receive the clock from the conductor. If the conductor is breakdown, is switch off, for example, immediately another device start to be the conductor. Immediately. The protocol have in your device a three of the second one, the third one of the conductor. Okay. Other very important concept is the bundle. Each network interface can manage a number of bundles. The bundle could be a container with the minimum 1, the maximum 8 channel of audio with 20 bits and for 48 kilohertz. We can have for each device a maximum of 4 bundles with 8 channels, a total amount of 32 channels, okay? And these 4 bundles can send to 4 receivers. But we can have, for example, 8 bundles or 10 bundles with a number of channels below of 8 channels. For example, I can have 3 bundles with 2 channels, which bundle a total amount of 6 channels, for example. The maximum amount of bundle is 16 because we can have 2 channels to each bundle. This means 16 multiply 2 is 32 channels. 32 channels send and 32 channels receive. Okay? The number of the bundle. This is very, 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 very important thing. We can have 3 kinds of bundle. We can have the unicast public bundle starting from 2056 to 65,000, okay? And this is bundle send from one device and receive to one device or at the maximum 4 receiver. I'm the sender. I use for example, the number of the bundle 300, send to Matteo, to Mario, to Luca, and to Sofia. If I need to send a 5 device, okay, over 4 device, I need use the multicast public bundle. This means that I need to use the bundle with a number 1 to 155 number. This means that I use a bundle, and this bundle by the switch is sent at all the network. I send at Matteo that I need to receive this bundle, but I send also to Rafik that you don't want this bundle. I send to all the device. For this reason, it's important to understand when you use the multicast and when you use the unicast. This is very important. In particular, for example, Ossia uses the unicast public bundle for the background music because it's one-to-one. When we send a message from the microphone to all the amplifier, the Ossia system use the multicast public bundle. But in this case, the microphone uses the multicast only for the time that need to send the message, not for always. At the end, we have additional unicast private bundle for the manufacturer, and this is a specific unicast private bundle. One bundle is more or less 1 megabit, okay? And in 100 megabit connection, we can have more or less 34 panels. This is an example to send from one channel to another channel, sorry, a channel to one device to another device. And this is the 2 port of our switch. The port was 100 port, and we use more or less the 9% of the bandwidth of this switch port, for example. Okay. If we use a multicast bundle, I see you that we have, for example, the port 22 and 24 for the device 1 and device 2. The port 21 and 23 is other device. When we use the multicast bundle, the same bundle is sent at all the port in the switch. For this reason, it's important to use pay attention where use one or the other kind of the bundle. You don't have to do this attention because the is automatically do from the VOCIA, but is just to explain how work the VOCIA system. Okay, I think we can go to lunch. Okay. Another important thing, but now is automatically, is the QoS in the switch. But the switch that we use now have a very high configuration of the QoS, and basically always is work fine without particular configuration. Okay. With normally we suggest to create a VLAN, a virtual LAN, to each network, in particular for the current device. Okay. I stop here.
We continue at 3.
I stop here. Go to lunch. We see you in the afternoon, more or less 1 hour, but don't worry. And we finish the overview, and in the end part of the afternoon, we try to go over in the VOCIA software to try to move the theoretical concept in the practical concept.
Okay.
Thank you. Have you question?
Afternoon.
Okay. Have a good lunch. Bye. See you later.
Good lunch.
Thank you.
Now we have the last two device, or basically to understand better the amplifier and the MS1 that are the main main device in your system. And after that, more or less half hour, we jump or start to see the software. Okay. Don't hesitate to ask what you want during this presentation. And do you have any question regarding the current protocol or other thing? No? Yeah, please.
So we saw that we have primary CobraNet and secondary CobraNet.
Yeah.
How do we configure these two on the switch? So assuming that we should have some cabling going to the switch.
Basically, the Kubernetes interface is both enabled always.
Yeah.
When normally you connect the primary to switch 1 and the secondary to switch 2. But, for example, if you connect both to switch 1, they work again. Automatically, when the device don't see nothing connected to the port 1, automatically switch in the port 2. But you don't have traffic in the port 2 if the port 1 is enabled. It's completely automatically the switch between port 1 and port 2.
So
Okay, have you, I reply to your question?
No, the question was about the switches, switch configuration. Is there any configuration on the switch, or should I only plug it? It use some standard protocols.
Standard protocol with nothing to configuring in the switch. The important thing is the same VLAN. Okay. Not a different VLAN like other protocol. For example, another protocol, Dante protocol, the primary need a VLAN for the primary, the secondary need a different VLAN for the secondary port. No, Kubernetes don't work in this way. Kubernetes have primary and secondary in the same VLAN and enable the secondary when the first is broken, or the port, the cable, it's broken, automatically start to send the information by the second port, the secondary port.
So the device is using one IP.
We don't have IP. It's a layer 2. We don't have IP.
Yeah, we don't have IP, but you have said that we are using some VLANs.
Please, I didn't hear very well.
Can you repeat, please?
Near to the microphone.
You have said that we are using some VLANs, so we base our VLAN on some IP range, so we can communicate, or what?
Because it's a MAC address. They have the same MAC address for port 1 and port 2.
So it's
MAC address, the detection. Yeah.
Okay.
You don't have any IP address in the VOSIA device.
Okay.
Only 2 devices, but I show you after.
Because in the presentation that we had, there are some IP on the slides.
Yes, but this was just to explain other thing. Don't bring the IP address. Was to explain the layer, the IP, and blah blah blah.
Okay,
But not to bring. It's just to explain, okay, the concept.
Okay, clear.
Vado io? O vai tu? Finalmente sei riuscito a tirare su, ma se vai tu...
Io perché dopo le 4 ti ricordi che non...
Ok, è facile.
Okay. Now let's talk about the VR 8600. This is, as Marco said this morning, this is a modular amplifier that you can. Sorry?
One more question, please.
Okay.
You said that from master to secondary, they changed directly automatically. Could you give us more details about based on what they can change? More details on the protocol.
Is automatically for the protocol.
Yeah,
When
but how?
You can change nothing in that. The support is always enabled. Always, both. When is both connect, the primary is with a priority over the second. Okay? But is both connect, both enabled. When one port don't see the system, the interface try to communicate by the secondary port. This is automatically. You connect the port and they work. You don't have to configuring nothing in the switch. Okay?
Okay, if it is clear, let's continue with the PA8600 OC amplifier.
Yeah,
As you can see from
ahead.
Okay, thank you. As you can see from the back panel, it is a modular amplifier that you can equip it with at least 8 AM600 card. Each card can be configured in 100 volt or low impedance according to your speaker lines. And then, as you can see, it is equipped with a NM1 card, which is the Cobranet card for the Cobranet communication with the other devices in the system.
And just a small information. The third port not is enabled. Okay?
Yes. You see that the NM1 card is equipped by 3 ports. 2 ports are for Cobranet.
The third
is not enabled. The one that you see near to the NM1 label. Okay. From the hardware point of view, the amplifier is a 3 rack unit. Okay. And each card, each AM600 card can produce from 100 to 600 watt per channel. So the total amount of power available with the frame fully equipped is 2,400 watt. So 8 cards. Each card can work at 100 volt, 70 volt, 8 or 4 ohm. So by the software, you can configure the single card to work in accord with the speaker line. So the card is only one model for each working mode. The device is also equipped with a dual Cobranet network port for redundancy, as we discussed before. And in the front panel, you have a comprehensive LED indication that report about amp fail, clip, fan fail, temperature, signal presence, and peak. And for my experience, these LED are really useful because it's the first troubleshooting that you can apply during a system failure. So you can detect for each card which is the problem. From the software point of view, you have a comprehensive fault monitoring. So you can collect all the single action that happen inside the amplifier during the functioning. And this is the different alert that you can receive. Inside the software, as we saw for the other devices, you have a fixed chain DSP, so you can act as you like from the volume, filters, dynamics, delay, speaker EQ, because if you use some biamp or community speaker, you can load the speaker preset for the proper equalization setting. Then you can also configure the Xover for 2 ways or 3 ways.
If you have a speaker with 2 or 3 ways.
Okay. And then you can also use the ambient noise compensator for this with this amplifier. Then we have 2 different approach for the failover, channel to channel or device to device. So you can the amplifier can act in 4-to-1 redundancy for the channel or 7-to-1 for the channel. In addition, you can configure 2 different amplifiers to back up each other. Another interesting feature is that the messages are stored inside the device, so the amplifier can work in emergency mode by itself. Okay, this is the same slide that we see this morning about the ambient noise control. So this is the specific device that allows to connect a microphone for apply the variation volume in relation to the ambient noise. Right? From the software point of view, you have to match the ANC1 ambient noise control with the channel of the amplifier that manage the line. Okay. And you can personalize the parameter in the graphic user interface also in relation to the ANC. The same for the end of line, okay, the device that verify the integrity of speaker cables between the channel output of the VA 8600 and the ELD1. Also in this case, the software is able to report the failure and which is the problem in this case, so short circuit, open circuit of cable damage. Usually this device is mounted inside the rack independently. And as you can see, you can work both in constant tension or in low impedance mode. The max number of device that you can install is 15. It's not related to the speaker line for power. So it works by itself.
Please, Marco,
Yeah.
I want just to know what's mean FFT based and ultrasonic testing. What's that mean?
FFT?
Yeah, basically inside of the signal of the audio, the amplifier send a very small audio signal to understand if the line is working fine. Okay. He send some ultrasonic testing because you don't hear that okay, during the testing. But need this signal, very particular signal, to understand if the line is working fine. Okay?
Quello del pilota sostanzialmente.
Okay. FT, it's the same or what?
Yeah. FFT is because it's a very very short, very narrow frequency that you cannot hear. Okay.
The pilot tone is outside the hearable range, so 20 kilo, for example. So it's out of the hearable range of frequency.
Clear, thanks.
Ok.
Al massimo passa avanti su questo. This card you don't have, and I prefer don't explain, but we have a similar card of that. The next one could be. Oh no. Sorry. We have a missing one card that is VFOM. VFOM 1. Sorry. We have a missing in the presentation. This card need when you have Matteo explain you that we can have the failover 1 to 7, mean to have one channel free and 7 channel working. When one of the channel 1 to 7 have a problem, this card can switch the load connector in the channel with the problem at the 8th card. For this reason, it's calling 7 to 1
All free.
or 3 to 1 failover. Okay. This means that if you see, this card is insert in the slot number 10, and we have a cabling to connect the number 1, 2, 3 to 8 at this card, and automatically inside the amplifier change the signal and the power of the channel when we have a problem in the channel 1 to 7. Okay? The other kind of the device backup is amplifier to amplifier. I check if I have an example. Mm-hmm. I'm sorry if we don't have insert in the presentation. Share my screen. We can have the redundancy in with 2 identical amplifiers, one master, the second slave. When you have a problem in the first amplifier, you have a total amplifier that replaces the first amplifier. Of course, the configuration is too expensive, okay? But we can use that. In this case, we need to cross this connection in the amplifier and they is in this part of the amplifier, okay? And each card is parallel between the amplifier main with the amplifier slave, okay? This is when use device to device, okay?
This is the other way to apply redundancy with amplifier.
Yeah, yeah. Honestly, there are repeat, please, near to microphone.
There is, I just asked Marso about the 3 cables. I saw that the first and the second are not the same in the other face, but the third one is the same. So what's the concept here for this cabling?
Because
These,
you have to cross
Yeah.
the contact, and then the one which remain the same is the ground.
Ah, this is the ground.
Yeah.
Clear, thanks.
Okay.
there are a third kind of a parallel or redundancy is channel to channel. In the amplifier, you can combine one channel to the second, for example, and if you have a problem in the channel 1, you have the second one to supply of the second, okay? In this kind, you have one-to-one channel to backup. In your configuration, we have also always the configuration 1 to 7 configuration with a card with one channel that supply when we have a problem in one of the other channel of amplifier. Okay? S1. Poi che tiro su io. Ok. Now we have the last step is the MS1. MS1 is basically a server with a different network port, and the MS1 have more of one function in the system. Go ahead.
Okay. As you can see, it's basically it's a PC, so a server PC, one rack unit, which allow to the main function is to allow the control of the system via different protocols such as TCP/IP or via VCA text protocol, so UTP. And you can also access to the system from the outside by VPN or something similar. And you can always use this device for this kind of communication. From the hardware point of view, the MS1 is mains powered, so it has a simple mains PSU. And the kernel is Linux based, so all the functions is provided by the embedded Linux system. It allows to store and play back 8 simultaneous messages. And it also allows to storage and services the whole system. So you can connect to the MS1 to manage all the system.
If you remember this morning, we talked about to have the ID to each device. When you remove an amplifier and put a new one with the same ID?
Yes, the MS1 provides the proper configuration to the new amplifier and replace automatically the faulty one. So this is a function that is available only if in your system is installed an MS1. Without, you have to configure the system manually.
And this is the first important function of this device.
Yeah.
The second one is the interword paging.
Yeah.
Right.
Yeah, you can, as Marco said this morning, with Vocia, it is also possible to create a communication between two different words. So two buildings for two different systems, okay, and with different words inside. And you can configure a communication between the two different words by the MS1. Also, in this case, this specific function is available also with MS1. If you need to create an intercommunication between two words, Vocia, you need MS1. Another important feature is the event scheduling. If you want to schedule the playing of a message at a certain time or a preset recall or something similar, you have to install an MS1. Also, the whole system event logging is available only with MS1. Differently, you have to read the log of each device, and you cannot have a complete log of the system. This is what I was saying before about VTP, Vocia Text Protocol, which is the proprietary protocol that allow to a third-party control with Vocia. So if you have an external control system or something similar, you can use this protocol to control the system from the outside. And another time, this is possible also with MS1. So as you can easily understand, is a very important device in order to connect the Vocia system with the outside, with the third-party world. Okay, and the system can be equipped with an MS1 or not, and it can also be equipped with multiple MS1.
Marco, please. For the VTP, to use it in
Yeah.
third-party control, we need a license, or it's free? They know about this protocol
No,
for other brand, or what the requirement?
It's included. You can use for free.
And in this situation, you need the IP of the IP address, for example. This is the only device with IP in the network of Vocia. Okay? Because this is the device that can see an external device. Okay? Is the bridge between the Vocia world and the external world. So clear? It's clear?
Yeah.
Yes.
Okay.
Okay. And then from the network configuration, you have 3 network ports on the back panel of the device, which allow the connection to covernet control, so to CPP, and a port is dedicated to the voice over IP, so to VoIP. Okay. About messaging, MS1 allows to to storage and play messages, so you can upload the message directly in the message server. And also the preamble or the chime related to paging station can be uploaded in the MS1. As we see before about the VA 8600, the emergency message, so the message that has been marked as emergency, are stored directly inside the amplifier. Okay. About the configuration, when you store a configuration inside a system composed by several devices, the MS1 is the device that contain the all the configuration for all the device, including the audio file. So in this way, you can act as a plug-and-play system in terms of configuration. So you can swap units in case of failure and so on. Also about the synchronization, MS1 is the central device that take control of the time synchronization in between different protocol or respect the NPT and so on. We have then a scheduler in the server, which allow 4 different type of events. For example, background source change, we can swap from a background source to another by the scheduler. We can recall and play recorded announcement. We can manage control handle, which allow us to report GPIO on different devices of the system. And we can also enable the user audio input. It's important to remark that all changes made to the scheduler are made in real time. So if you make a change, in the scheduler, it happens instantly. And then we have also the compatibility with NTP server support for time synchronization. The scheduler supports 8 simultaneous channels, so we can use a maximum number of 8 channels audio. And we can also install multiple MS1 per word. Okay. And the scheduler of each MS1 is shared across all the system.
This means that automatically MS1 is in the backup for the second, for example, in an airport or a railway station where they want to be sure don't have any fault of the message or other thing. And both the MS1 can work together to store, and both the information is stored and replaced in all the MS1. Pay attention, MS1 in the each word, okay? But now I explain the interword between MS1. Now Matteo explain.
Exactly. As we said before, the interword communication is possible by the MS1. So the aim is to have the ability to communicate between independent covenant words. So 2 different Garcia systems that are able to exchange messages between the 2 words. The communication is possible for both data and audio, so we can share control or audio signals. And in this way, paging devices as the microphone paging station in one word can make paging requests in another word. So you can use the paging station in one word to reach a zone in another word. It is important to remark that only paging audio is possible. You cannot share background sources. Okay. And all the words have to be configured in the same project file. So you have to have a single project in Vocia software for all the words involved in this kind of communication. This is an example of 4 different words with several Vocia devices that are able to communicate by the MS1 server. As you can see, there is a PC that control the system by the VOCIA software. And in this case, you can discover each device by TCP/IP and not by Cobra-net, because you can use the port 1 of the MS1 server. From this point, from the MS1 to the device, as you can see, the communication is only via Cobra-net, and you have another, from the topology point of view, another switch which are charged only for Cobra-net communication. In this way, we can realize what we described in the interworld communication.
A question for the IT man at the training.
Marco,
Which is, yeah,
okay.
yeah,
Go ahead.
tell me.
I see that there is a case, what we have is the same link, Cobra-net and EP. The green one.
Yeah.
Yes.
How it's possible?
In this example, not is possible. Why? If you see the word A and B and D and C, I ask you, is the same VLAN the word A and word C, or different VLAN?
Should be the same.
Are you sure?
Yes.
No. For the reason that the protocol of Cobra-net, if you remember, use for the background music the unicast bundle, point to point. But for all the other call, microphone, emergency, and so, the multicast, broadcast, send one message to all the device. If we have only one VLAN for these 4 words, the number of the possibility message together are reduced a lot. Okay. Instead, if we have a VLAN for each word, this means that you remember, for example, the example we show you this morning about the airport with the gate. For example, gate A, gate B, gate D, gate C, okay? With a lot zone, a lot microphone, and so. Basically, when you send a message in the word A, normally that message is for that building, not for the other. The message with all the airport is not so common. Is, I don't know, one call in a day, for example. In the other end, the call to the single gate is a huge number. Okay. For this reason, we need to have a VLAN for the Cobra-net part in the word A, separate from the word B, and separate of C and D. Each word, each system have a proprietary VLAN.
But Marco, please.
Yeah.
According to what I know, different VLAN need an IP to communicate, if it's the same concept. And you said that we don't need IP in our case.
Yes, it's correct. But for the building A, okay, all the VOCIA amplifier, VI6, paging desk is in one VLAN, okay? And the MS1 is connected with one port in the VLAN inside the building A, okay? The second port of the MS1 is connected with the interward VLAN. Okay? The MS1 is like a bridge for the internet, like a router in the internet. Is better? Is clear?
Normally should be a trunk between the words.
Yeah, but don't. We are talking of VLAN, not the switching configuration. Okay?
Yeah, but is this VLAN has the same concept like the networking VLAN, or it's different? Because, as you said before, the concept of bundles. For multicast, for example.
Yeah.
This is a different concept. That's what we use in VLAN, or what?
No, Andrea ben su schema.
Ok.
Solo che non riesce a vedere il mouse.
È lento.
Okay. I try to explain you.
Marco, one question. In the same word,
Yeah.
the data, we saw in this morning that there is different type of signal inside. There is evacuation signal, there is control signal, and data. For those different signals, they are in the same VLAN, or each signal have dedicated VLAN for that?
The same VLAN.
The same VLAN. So here in our case, the word A, for example, VLAN 1, word B, VLAN 2, word D, VLAN 3, and like this.
Yeah. For each VLAN, we have one MS1, okay? The MS1 have two ports. The first port connect with the VLAN of the building, okay?
Okay.
The second port is connected to a different VLAN, where this VLAN is connected between all the building. The red VLAN, okay, is a VLAN shared in all the building. The blue VLAN is inside of the building. It's better?
Yeah.
More clear?
Inside one word. How can the system separate between those signals?
Can you repeat the question?
For CobraNet protocol, we have so many different signals. How we can make a difference between them inside one equipment? They are in the same cable, the same VLAN.
But is it automatically by the bundle, by the CobraNet protocol?
I know it's automatic. Do you have an idea about the details of the protocol? How can we tag that this is a data and this is evacuation broadcast and this is a control packet?
Because inside of the, if you remember my slide this morning, inside the bundle, he can write, they put inside which is the zone enabled for that bundle, okay, and which is the priority of this channel, okay. Automatically, each device in the that VLAN in that word receive this information, is a broadcast information, and if I'm the amplifier with that zone where is the end zone right in that bundle, I open my channel. If I'm not that channel, that zone, I didn't open that my channel. Have you understand?
Yeah. So this is the meaning of the bundles. We use it for this purpose.
Yeah, but it is inside of is automatically inside of the VCA system.
Yeah,
We don't.
for the Cobra Net protocol.
Yeah.
This is the
The important thing to understand for us is the use of two kind of bundle, but is for us automatically from directly the VCA system, unicast or multicast. The other thing to understand is that we can have, in your situation, we cannot have only one VLAN for all the building. No, it's impossible. We need to have for the building A, one VLAN. For the building B, one VLAN. For the building C, one VLAN. And only one port of the MS1 is connected by an inter-building VLAN. Okay?
Okay.
Try to think the red network is internet, okay? And the MS1 is your router in your house. Okay?
Yeah.
Is more or less the same. Inside your house, you have your IP address range, okay? But if you connect your house with the house of your house near husband, can have the conflict, okay? For this reason, you have the router in your house, correct?
Yeah. Marco, please, in our case here, if you want to connect a VCA device to the switch user for EP, in the central, the big one, and connect it to one of the MS1 in this schematic, is it possible or not? As an extension.
MS1 port to red VLAN have the have the IP address.
Yeah, but is there any possibility, for example, in MS1 app, we connect directly on the switch a VCA device?
Between the red VLAN?
No, not the VLAN. The bigger switches in the central. If we connect one VCA device inside this switch and we want to connect it to MS1, is it possible or not?
It's possible if that device is connected to the covered port of the MS1.
basically say if the Kubernetes port of the MS1 is connected to the main switch.
The MS1 have two ports, one Kubernetes and one interworld. Okay?
Okay.
If you connect an amplifier in the interworld port, don't talk. If you connect the amplifier in the Kubernetes port of the MS1, easy connect.
Okay, so there is no way to have the both on the same channel.
No.
Okay. Marco, please, I have one question about the MS1 storage. As we said in the presentation, all the device of Lucia configuration are stored in the MS1.
Yeah.
This is only for backup if we lose one of the config inside the device, or all the device are connected to their configuration inside the MS1.
No, the MS1 have the complete configuration of that word. Okay. When you connect a new device without any configuration, the device, for example, an amplifier, check in the network. The network see that you have an MS1. The MS1 see the new amplifier, check the ID, the rotary encoder, is the same in the list of the configuration, is the same amplifier model. Okay. Have you the configuration inside? No, because it's a new one. Okay. MS1 start to send the configuring of that specific amplifier. When I have finished to configuring, the amplifier start to work automatically.
Okay.
It's clear?
Yeah, it's clear.
Of course, each MS1 have the configuration of that word, not of complete universe. Okay?
Yeah. If we lose the MS1, the devices, the amplifier is still working with the emergency
Yeah.
zone.
Of course, yes. You can switch off the amplifier. Sorry, the MS1. The local word work. Okay? But of course, if I switch off MS1, what we lose? We lose the backup, of course. We lose the interwork calling from one building to another building, okay? And we lost the store and forward message, because the store and forward, when I talk in a microphone and in another microphone is in the same time, okay, that function is created by MS1. If you switch off MS1, this feature, you don't have this feature, okay, in that moment. But all the other things work perfectly. When you have only one building, normally you don't need to have an MS1. You cannot have an MS1, okay? The system can work without MS1. When you have a lot of building, you need MS1.
So for our architecture here in the big mosque, we have one MS1 for each building.
Yeah, correct.
Okay.
Yeah, correct. If you want, I can show your configuration. I open the file, one moment. is too heavy.
About if two devices in the same word have the same idea.
That one I don't know. You can ask. You may trouble in MS1 because it discover two different MAC address, and you don't know in which one. Maybe you have another because you have always, if you watch on the software, you have always.
For example,
Marco,
Sì.
mi hanno chiesto se erroneamente mettono lo stesso ID su due amplificatori.
Okay, this is a problem. Theoretically, the same amplifier bring the same, both amplifier bring the same configuration, but it is an error. Okay, theoretically, they can have the same ID inside of the same network. You can have, for example, building a amplifier with ID 1 and building B in different VLAN with the same ID, but not in the same VLAN. For example, this is a schematic of your system in the Minareto. For example, we have 3 different racks, okay? Now I zoom on. This is your configuration, your system. We have a 2 switch, okay? We have the C1 and MS1. The MS1 have 2 different ports, control and covenant. The covenant port is only here, only in the VLAN of the Minareto, where we have 1, 2, 3, 4 amplifier, but we have a second rack with other amplifier, 1, 2, 3, 4, 6, 7. In total is 10 amplifier, okay? This is in the same VLAN. If I jump, for example, in the building C, this is the building C. The building C, we have another MS1 with the same control and covenant. Here we have, for example, 1, 2, 3, 4 amplifier, 6 in one rack. Jump in another rack. We have other 1, 2, 3, and 4 amplifier. Jump in another rack. Sorry, my PC is going now. And we have other 3 amplifier, 1, 2, and 3. Basically, the VLAN of the building C is a VLAN only for the building C. The VLAN for the building B is only for the building B, but we have this port, only this port, the control port, only that, okay? Only this port share with the other MS1 in the other building. It's clear? Okay. I try to jump into the, one moment. I try to see you the last configuration. This more or less is the configuration, the software for configuring the VCA system. Okay? This is just to show you your configuration. Okay? But this is just to show, and after I try to go step by step to explain better. For example, we try to reduce you have a huge system, okay? This is the universal. I call Moschea N, B, C, D, E, F, G, H, K, M. Inside the universal, we have 8, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 words. Okay? Each word, if I switch the right button, I can configure the universal, okay? Or if I go in the word, right button, configure the word. Okay? when I go in the universe, this means that I configure for all the Muskia. When I go inside a building, this means that I configure that building. Okay? Now I tried a building smaller to be too simple, probably. I tried with the building K, okay? Configure the word. This means that I'm configuring the building K in this case. Inside the building, I have all these things to configuring. In particular, in this building, we have created 3 zones, only 3 zones, okay? We can create and write the number of the zone, and for each zone, I can associate the a name, for example, okay? For each word, I can create the page code. In this case, we have created only one page code with the number 999, okay? And this page code is a preamble. This means that you have the chime, the ding-dong before to toll, is a live page code, a live message, but if there are other messages, you can store and forward. Okay, we have enabled this feature. The priority is priority 1, very basic. This page code go in the zone, you see, the only in the building K, zone 1, 2, and 3. Very basically in this way, this case, okay? Clear? Right now?
Marco, for the category of each one.
Okay, you can, if you want, create, for example, many categories, okay? For example, I don't know, rooms, okay? I don't know, corridor. And you can create how many you want, okay? Just a label, external, technical room, okay? And if you want, I can create how many page code I want, okay? And I associate to the page code, for example, a name, okay? It's clear? Just to read better your configuration. Okay.
Okay, Marco, about
Go.
about the priority.
Yeah.
How many priority we have, and what's the relation between this one and the quality of service that you told us this morning?
The quality of service is only a concept for the VLAN. Okay. Not need for the priority, another thing. The priority is when I bring my microphone, I push page code 1, okay? and I push the microphone button, that paging send a bundle to all the device, okay? In this bundle, the paging desk add a small word where write the priority of this message and which is the zone where I send this message in according with this configuration. Okay?
Okay.
Yeah. This microphone send a message from that microphone. I have a second microphone that in the same moment push another page code, okay, with a different priority and different kind of zone. If the zone not is overlapping, the two microphones go for two way different, okay, with two different bundle. If for example, this microphone send to 1, 2, and 3.
Marco, we
And
can't
this,
see you if you try to end. We can't see you.
you don't, you see the camera or no?
Just a
No.
part, just the middle.
Sorry. For example, the first unit call this zone and this call that. This is, for example, all. Okay. It's clear?
Yeah.
Corridor, external, all. Okay. If the two console send a message, one to external and the other to corridor, we don't have the same message in the same zone. Sorry, the different message in the same zone, okay? Because it's a different zone. If one of them call all the zone, for example, that go over to the other, correct? The system, in this case, use the configuration store and forward, and the low priority message is stored, the other one go, and when finished, we have the first message, okay? What do the VOCIA system? One, send to the channel 1, for example, with all the information, where goes that message and the level of priority. The second one, use the bundle 3, for example, with the destination and the priority. When the amplifier receives that information, combine the two information and bring the bundle with the high priority level, okay? But for us is only to configuring correctly that part. We don't do any other thing, okay?
Yeah.
I talk of page code. The page code is the normal page code for calling in normal situation. Okay. We have a different kind of emergency code because we have, this is the normal emergency code, this is the normal page code, and this is emergency page code. Okay? The emergency page code have a priority over the normal page code. Okay? You have here other 255 level, a priority level. Okay? 255 for the emergency code and 255 for the normal message. About over 500 priority level. Okay? This emergency code would be a different call, a different way, a different, you can create what you want, okay? Normally is the same, but could be different. Clear? Important thing is two different page code for emergency and for normal call.
Marco, please.
Yeah.
How we can configure the zones and even the emergency zones?
Yeah.
How we can configure even the output of amplifier, the lines in the zones?
Yeah. I try to show you.
Okay.
Inside of the out, we have now these different part, the different kind of object. Input, paging desk or VI6, output, amplifier of small amplifier or big amplifier, not is important, okay? Controller for fire alarm system, and processor MS1. Inside the amplifier, when I open the amplifier, we configuring the, here we have our 8 line of amplifier, and each line can have a name, of course, and I associate the zone for each line and the emergency zone. If you see, we have in this case only one emergency zone for all the building, but we have split the building in 3 zones for calling, for example, I don't know, floor 1, floor 2, floor 3, I don't know, I don't remember, okay? If you see, we have here only one zone. Here, 3 different zones. And each zone have 2 lines, 2 amplifier lines. Okay?
How we can know that zone 1 contains line 1A or 2A or which line?
Can you repeat the question because I didn't hear very well?
For example, zone 1
Yeah,
contains which line? How we can know it? How we can configure it?
1 and 2. The zone 1 is that, correct? Zone 1, for example, I change the name because probably the name is, for example,
Yes, here we can see it's VI6, building K VI6, channel 1.
floor 1, floor 2 and 3, for example, and I don't know. Okay. Now, just to explain better, for each line, I can choose, for example, for line 1A009, I can associate at the zone 1, 2, or 3. In this case, floor 1.
Okay.
I have replayed your question.
Yes, thank you.
Okay, is too clear?
Yes, thank you.
This is the how many zone I split the possible calling from the microphone. Okay? But in this example, we have only one zone in case of the emergency zone. When I send a message, emergency message, evacuation, for example, I send at the same time for all the zone. If I want to split the emergency zone of that building in 2 zones, I need to go in the emergency zone, create a second zone, okay, and associate that amplifier a different zone. Okay? If you see, we have a very strange configuration, but just to show you what we can do. We have floor 1 with the line 1 and 2, okay? The channel of amplifier 1 and 2. Floor 2 with the line 3 and 4. The terrace are the line 3 and 8, but the emergency is strange because I associate to zone 1 the first 3 line, 1, 2, 3, and the line 4, 5, and 6 the second zone. Okay, it's just an example. Okay, not real, but just to show. Clear?
Marco, please. How many line we can add to each zone, and if there any
How many you want?
And if there any possibility to have one line in 2 zone different, 2 different zone, 1 line.
No, one line is at least 1 zone. For example, can have an example here. Tenants is only one line, okay? I can split the message of one amplifier in two different amplifiers. No, it's impossible because this is one line, okay?
But
In one
sometimes,
line,
but
please go.
maybe sometimes you need to share this different message in the same line, in different event.
Yeah, but if you have one cable, one is the cable, one is the information.
Yeah, of course. For that, it's clear, but not in the same time. Maybe if you can share the message according to the zone, not to the line.
Yeah.
So if you have the same line in two zone, you can program two message. It's not can't be in the same time, but in different event.
Pay attention. The zone is the zone. You can, for example, I explain in another idea your question. Zone 1, zone 2, okay. Now I associate 1. Sorry, probably I didn't. Zone 1. I didn't save. Okay. Now I go in the amplifier. Zone 1, 2, 3, 4, 5, and I needed the 7, but okay. But this is the single line, okay? Inside the message, I can create the page code with zone 1, zone 2, zone 3, zone 4, zone 1 plus 2,
Okay.
zone 1 plus 2 plus 3, okay? Zone 1 plus 2 plus 3 or 4, okay? And so, and when I associate for each page code, sorry, I write 1 and 2, 1, 2, 3, 1, 2, 3, 4. Have you understand?
Yeah, now it's clear. And after you share the message on the page, not on the zone.
Yeah.
Yeah,
This is the zone is basically the least the smaller area where you want have together. Okay. For example, floor 1, floor 2, or what do you want? Okay. Sometimes it could be one line, but sometimes could be a lot different line. And for example, in the building C, you have a lot amplifier, okay? The amplifier 1 have, for example, zone 3, 4, 27, 28, and 29. But if I go in the amplifier 2, probably I have the same zone, you see, for the redundancy reason, okay? You understand that?
Yes, clear.
Two amplifiers, two lines, the same zone, okay? Just to explain why we need to have zone and page code and line, okay? I come back in the configuring of the word. At the same, we can change the different emergency zone or create how many emergency zone I want. The same for the emergency code. I can have only one emergency code for both the area, or I create, for example, emergency code emergency zone 1. It's clear? We can have, similar to the paging code, the emergency code can have one or more emergency zone. Okay? And the emergency zone is different of the normal zone. Okay? Is two parallel programming from the emergency and normal programming. Clear? Here we have the emergency message. We can create how many emergency message we want. Message 1, message 2, 3, 4, 5. And for each message, I can bring one message and put inside of this configuration. When I finish the configuration and I send the configuration to the system, the PC bring this file and send inside to the amplifier. Okay? This file is stored inside the memory of the amplifier, not inside of my PC, on the amplifier. Okay? I can change the message, try, and many other things. I have shown you the configuring of the amplifier. Okay. Here we have other kind of configuration. We can write the description of this amplified line. We can change if a channel, group, or multi-way in your situation is a channel. Okay, always channel. But if you want, you can create inside the amplifier a group like have the same. A group is more or less the same that you do here. Okay, I prefer work with a channel, for example. You can choose if 170 volt. If you have other kind of amplifier, you can choose 170 volt or 8 or 4 ohms. And you can enable or disable a switch relay when you have the paging inside of this zone. This is another feature. If you want send by an external system the background music for each channel. For example, we can have a Tessera system and send a background music directly to that zone, or better, directly to this line by the bundle for 4273 channel 1. Okay? Channel 2, 3, 4, and so away. This means that I send directly the background music in that channel. Okay? Here we have other configuration of the amplifier. Here we have the audio configuration for each channel. This means that we have a filtering, equalization for each line. Dynamic, this means we can enable, we can choose the compressor, limiter, and so. We can add an additional kind of equalization. Okay. I just to show you. Okay. And in case we can add in a delay for this speaker line. Here we have a control of the volume for each channel. You see that we have 7 channels, but there are an additional 8th channel because I configuring the amplifier like 7 to 1 channel. In the option, we can choose if the amplifier is standalone, 1 to 1 channel. This means that we have a secondary amplifier in backup at the first amplifier, 3 to 1 or 7 to 1 channel. Okay, this is the configuration that basically you use in your system. Here we have other checkbox. For example, if we use the secondary covenant port, if we don't use, we unflag this checkbox because at the other end we have a constant error in the log file. Okay, because we don't have connect the second cable. And other important feature that you can see. Level, alarm, and log, you can see and read all the log file of this amplifier. If we have the
Marco, please, for alarms.
Yeah.
We can detect problems, for example, if we lose a part of speakers in the same line. How many speakers? Is there any method to identify each speaker with the amplifier?
yes or no. Depend of the how many loose speaker you have lows, okay, and how many loose speaker is in the line, okay. Basically, you see, depend of this parameter of this parameter, okay. When you use the PLD calibration or the LD calibration, you can, okay, choose this. Basically, you use the PLD2 or PLD1. This is the underline passive module, okay. The system check a calibration, okay, when you start the system, and understand more or less the system have a picture of the situation of now. If tomorrow you have a big change of that situation, the system show you that, or tell you that there are and high impedance changing on something else. Okay? I have replay your question.
Yeah, the calibration module, it's a separate module that we install in the end of each line.
Yeah.
So
Yeah.
if we lose the connection with this detector, the system detects that there is a problem in the line.
Yeah, of course, yes. Yeah.
But I think this is not the case. If we use, for example, I think here in the big mosque we have no active speakers.
I didn't understand your question, the last question. Please replay. Repeat, please.
1 minute, Marco, please.
Because I wanna try to explain them. Now, noi adesso ce l'abbiamo installati questi, giusto Marco?
Yeah, yeah.
Okay. Now we have that installed. When all the speaker, they are okay, and you know all the speaker function, you don't have problem. You have a value if you install the end of line, okay? When
And you have, and you push the button to have the situation of today. The situation of today is good. Okay?
yeah, you push when you finish to install all the speaker in your line, you press the button, you have a value. It means today, that hour,
Tomorrow,
the
just
value
mean
is that. Tomorrow you lose because they modify, they cut Ronnie the cable. You lose a part of speaker. You have different value, and you have a log, an error. You miss some speaker.
okay?
You have to follow. You have to follow which speaker where they cut the cable.
In some case, you have more than 15 speakers.
Or 60, yeah.
Yes.
You have to follow the line. Yeah, there is nothing to do.
Okay. I think that they didn't install the PLD.
Yeah, they installed it.
Okay. Okay.
Now it's clear, Marco. Yeah, thank you.
Okay. Don't worry. If you don't have ALD1 or the PLD, you can use the high impedance monitoring. The high impedance monitoring to each line, okay? What do? We enable an impedance monitor for the channel. We can have a piloton at the frequency that I choose here. Okay. For example, 53 hertz, okay, 19,002 hertz. Basically, we chose the frequency that not is possible to hear from the people or from, normally. Probably this frequency heard the dog, but not the human, okay? But normally, some loudspeakers don't reproduce this very well, this frequency. And when you are connected, the amplifier generate that frequency, show you a value of impedance, and you write the right impedance that you read today. Okay? For example, 19.3.5. Okay? 19.3. Okay? Here we can have a tolerance in percentile number about this frequency at this, this impedance at this frequency. Here we can have a different impedance because at each frequency, the loudspeaker, the line of loudspeaker can have a different impedance. For example, here we have 2045, okay? And here we can create a
Marco,
different
please.
tolerance.
Could you
Yeah.
zoom on a little bit? Could you zoom on?
Zoom.
On the screen, it's not very clear.
Yeah, because you share your PC on Teams is not very good, the quality. If you can increase the zoom of your PC, because
I
if not,
try.
we don't see very well.
I try, I don't know if
Perché
I
è condiviso il tuo schermo, Marco, e quindi non vediamo.
Certo, no, provo, ma non so se riesco a...
Normalmente sullo schermo, sulle configurazioni dello schermo gli dai la percentuale più alta.
devo...
But the important thing is, okay, you send the frequency. You don't have the end of line, okay? The equipment installed. You send the frequency. You know in the beginning today all the speakers they are in good condition. You read the ohm, the impedance, and you make a tolerance to the impedance. It means if you
better.
lose some speaker, the impedance change, and you have the alarm. If you have installed, if you don't have installed that equipment, you can do the same like this. Okay.
You see better now?
Yeah.
You see better?
Yes.
Okay.
Yes.
But basically you don't use that, okay? Because you use this configuration. Okay? Okay? I show you the amplifier configurator. Do you want to have a small break? The last few minutes. The input of the system. We can have a different kind of the input, but basically the DS or AVS is more or less the same. Double click. We have the possibility to enable in this unit all the paging, or only one? Or what do you want? I try to do an example. You have the airport, okay? Each gate have a paging desk, okay? And each single microphone can send the message only in that gate, okay? Or the gate and the near gate, for example. From the info point or another point, another paging desk can send a message to all the gate and choose which gate want. Okay, you can choose if show in this paging desk all the possibility or only one, or what do you want. You can assign the preamble, the chime, okay. You can enable, if you want, a ping access to enable or disable the paging desk. For example, in the gate, you go and push the button and send a message. No, because if you don't write the right page code, the correct ping access, you don't enable the paging, the microphone. House report you don't use. Other option, after house second, the unit go in security mode, okay? Audio, you can have an equalization of the unit, okay? Create an equalization, or insert a dynamic filtering or compressor limiter for this microphone, and you can move the volume for the microphone or for the chime, okay? If the chime is too loud, you can reduce or increase what you want, at the same for the microphone. At the end, the alarm. Pay attention that this is the name, this is the description, okay? And this is only to understand or for see better your configuration. But what is the important thing is the ID. The ID is the ID of your rotary encoder of that specific microphone. If you broken that, bring a new one, rotate the rotary encoder with the number 83, and automatically the new microphone receive that configuration. Okay? For the AV, this is the emergency workstation. For this reason, you cannot choose the normal message, the normal page code, but you can choose only the emergency page code, okay? This is different if we see that and we see that, because are two different kind of, this is the page code of emergency. This is the normal emergency page code. Page code, emergency page code. Okay? At the same, you can choose the priority level of this unit, the security, and similar to the other unit, you can change the dynamic, the compressor limiter, the volume of the chime, the volume of the microphone, and the filtering parametric, or which kind of filter that you want, you can choose and enable here. Okay. If you have, for example, I want to have the same configuration of the
We lose sound.
microphone. And sorry, you see? You see again?
Yeah, it's okay now.
Sorry. We can write a Q mic Marco, for example, and store. Okay, save. And I go in another microphone. Okay. And I can a Q mic microphone and automatically record this configuration if I need. Okay. At the end, we have the P.
Marco, please.
Yes.
For DS10, we can use only the zones of the word, its own word, or we can use the zones of other words.
No.
For example,
only,
here for building K, we can add the zones of building A or C, or it's not possible.
Good question, and because it helped me to explain another thing. The page code is creating in each building. Okay. This this microphone can choose the page code of this building. For example, building K, correct?
Okay.
If I want by this unit talk in another building, I can create a new page code, or building A. I create a new page code. This is inside the building K, and I chose what? In the zone, I have the zone of a building K, but I can choose all the building A.
Okay.
Okay. And in this page code, I select building B, all the building B. Okay. What mean?
We created the region.
When I now enable this page code in the my microphone, when I push the 001 page code, I call someone. I call in my building.
Okay.
When I write 008, I call building A.
Okay.
This means that my microphone push 008
The output will be in the
send to MS1, MS1 by interword send a message at the other MS1 in the building A, and the building A send a message at all the building A from the microphone of building K. Okay?
Okay,
I
okay, thank you.
I try to explain another example. In the building K, I create a page code called Moschea. Okay? Here, I select all the building. Okay? Or another possible is building A plus office K. Just an example. I select building A, and then building K, I select only zone 1 or 2. I don't know, just to explain you. Okay? Now, by the microphone, I can choose all the Moschea. This means by the microphone, send a message in my building, and at the same time, I send by MS1 the message to all the other MS1, and each MS1 send a message to all the building of that MS1. This is an example. A second example is 1011. Building A, when push the page code 011, I send a message to building A total, and only the zone of office of the building K. Okay, but you can do what you want. You will see that it's very simple to change any configuration of the here how you want. Clear? Better? I replay your question. Okay. The last is the VI6. The VI6 is the input of Lucia. We have the 6 input, and each input we can configuring with or like a background, for example, CD, MP3 player, web radio, I don't know, okay? Or in another way, input from TV, CC, I don't know. Input from
Web radio.
I don't know, other security. Okay, this is an audio input, and I can use like a user, but in this case, we use like a paging.
The input can be the microphone that we used in. Don't know.
Microphone.
Tall and low, please.
The input can be make a microphone.
Could be a microphone level or an audio level. What do you want? I can choose here the level of each single input. Okay, but when I create that, I can choose where I can send this microphone. Okay, why I cannot page code? I don't remember why I cannot choose. One moment. Non posso scegliere un page code. Ah, perché questo è un V6.
Sì, ci vuole l'8
Ci vuole l'8.
perché può essere di emergency.
Yeah. I'm wrong because this is the VE6 and not the VE8.
Yes.
If I adding a VE8,
We do not have it in.
I can enable like a page code.
It's not our case.
Okay. I can choose here. Other thing in the big six, we can choose the preamble if we need. Okay, and choose the kind of the chime, three tone, anything. And at the end, you remember that we have some control input and output logic output. We can select how we want to use with this control input, for example, for each control input. For all the device, we have the DSP part. If you ever see each microphone, each amplifier, each device have the DSP of to manage the audio part with the EQ, delay, compressor limiter, because each part is independently to the other and have inside the DSP. For the reason that we don't have a central unit, but all the unit spoke with the other unit. Okay. Here we have the channel, the filtering for each channel, 1, 2, 3, 5, 6, EQ, okay, or some EQ, okay, dynamic for each input channel, and here you can see if you have enable, disable the input, the logic input, or the status of the logic output. You can change, but you can see here, and see, of course, the alarm log. Okay, I think for today is enough. Today we have seen more or less the configuration of the word and the input and output part. Tomorrow morning, we check and show you the LSE16 and the MS1 configurator. And we show you to configuring this device just to show you how we can do to go online directly with the device. Okay. If we finish not a good time, we can start with the Tesira part. At the other end, we can start the Tesira part the day after. Don't worry. Okay?
Okay. Thank you.
I ask you to write your name signature for the present
already
for you
done.
because you need after your register the presence.
It's already
Gentlemen,
done.
thank you very much for your attention and see you tomorrow.
Thank you, Marco. See you tomorrow.
Thank you all.
If in the night you have a question, don't worry, sleep, and tomorrow we reply you.
Okay, inshallah.
Bye, thank you very much.
Bye bye. Thank you all.